Welcome, everybody, to the SRT open meeting. I'm thrilled. I'm a bit nervous, right? And I'm nervous to remember everybody's last name. So I'm going to introduce people. John from the NFL, right? Glenn, ESPN, Dave, Azzurro, thank you for being here. Jeff from Microsoft, and Olivier from Collabora. So the point of today is to let everybody know a little bit about SRT, what it is, why it is, where it came from, but most importantly, how it helps people get their job done, right? And so I'm going to walk you through a little bit of history, if that's okay. SRT stands for, I'm sure all of you know, Secure, Reliable Transport. And as my friend Silvio says, probably the fastest growing open source streaming project that has ever existed. We just held our members meeting before this, and I'll debrief on some of the excitement that was discussed there towards the end. So where did it come from? This is, what is that? That's the original design document, right? And it's actually the edge of a wine box. And after going to IBC in 2012, and a lot of people came up to the Haivision booth and said, "Listen, we've got to get down from satellites. We've got to get off MPLS. We need a better way to do things." And so we took that information home, and I sat down with Mark Simantowski, one of our top guys. Mark's right back there, and we sat down and we hashed out some ideas. So this was November 2012, and in September 2013, we did the first demo, actually the first live HEVC encoding, and we actually piped that first live HEVC stream over SRT into the RAI Convention Center. And that was kind of revolutionary. And for any of you who are interested in kind of the technical developments, there's a great article on GitHub that Mark wrote explaining kind of the technical progression of the technology. So later, probably in the spring of the next year, we released SRT as part of our product family. And our clients started enjoying the benefits of very low latency streaming, secure across public internet. And then, the story goes on and the story goes on, and, it starts infecting all of our products. And then, I think it was last IBC, a year and a half ago, where we kind of said, well, this is just Haivision, and how are we going to, expand the footprint of SRT? And our company was so excited about it, but where is it going to go? And so I had a chat with my friends at Wowza, right? And I said, listen, guys, what happens if you supported SRT as well? And so the discussions went on, and it's a technology and a technology stack and a protocol, and we were talking about licensing and stuff like that. It was actually Dave at Wowza who said, you'd really make the whole process of getting adoption a lot easier if you went to open source, right? So last NAB at 9 a.m., we released SRT into GitHub as an open source technology stack and protocol, right? And I think the market, well, considering all of the great people in the room here, the market was certainly very thirsty for that technology. And it's been a very, very exciting year for Haivision, for SRT open source, and the SRT Alliance. Since that time, and I think I'm missing going through some slides here. This is what SRT is. So the fundamental of what we designed into SRT and what we were trying to mandate or develop is, give me a node that you can put at the end of virtually any network link that provides packet loss recovery, so you can get over any network. It provides security. It's always focused on low latency. And give me this package that you can apply anywhere in your video workflow. And so that's what we designed, and that's what we developed, and that's what we put into GitHub last April. Now, the story, I hope I'm not boring you, right? I'm just telling a little bit of makeup here. So the story goes on, right? At 9 a.m., it was released into GitHub. By noon that day, the first integrator, Kevin at D21, had it up and working on his platform. So it's easy to integrate, and everybody is really, really thirsty for this stuff. The story goes on, and the year evolves, and there's been some amazing moves in the industry related to this technology. We have, I think now, 106, 107, somebody chimed in this morning, joining the SRT Alliance. The SRT Alliance is kind of the marketing vehicle to progress the excitement towards adoption of the open source. Some of my favorite supporters, and I kind of break the supporters, the SRT supporters, and the thirst in the market into two categories. You've got the streamers who are looking for a replacement to getting stuff to the cloud, an evolution of what RTMP, where RTMP was heavily used, and Jeff's going to talk about that. But you also have the broadcasters who are looking for non-proprietary, open standard ways to get the job done of backhaul contribution and distribution. So there's kind of two classes. One of my favorites is actually Eurovision, and I don't know how much I'm allowed to talk about it, but they came into, I think everybody knows who Eurovision is, yes? Is there anyone from Eurovision in the room, first of all, before I start talking about them? Good, no. So what was really cool about Eurovision is they needed a new way to power their contribution network. And they actually took the SRT open source and developed a worldwide contribution network based on SRT, actually with very little involvement or product from Haivision. So it was really kind of this organic development that they did, and really amazing. And part of the open source collaboration is people working together to make this thing better and better and better. And actually they, Mahmoud, I'm correct, sorry, Mahmoud Al-Dakak, our CTO, I'm correct in saying that they actually helped with the latest build of SRT and carving out some problems.
Actually, they jumped to 1.3 before we actually tagged it, so they were doing a lot of beta testing for us.
Yes.
So we thanked them for that. But they were really aggressive in adopting the latest and greatest.
So it's this collaboration, this independent collaboration to adopt and make the technology better and better and better. That's so exciting. So with that, that's kind of the in a nutshell, the story of SRT. I'll get in after the discussion. I'll get into where you can see it on the show floor. But I'm actually amazed. Yesterday I was walking down the center of South Upper, and then there's Blundertongue, and there's this company, and there's that company, and they're all SRT supporters, and they all have SRT implementations. So it's really, really exciting. I even saw, if you walk by the Appear TV booth, they've got a blade in their chassis with SRT written on it. So it's being adopted, it's being used, and it's solving some really, really great problems that people across multiple industry segments have. So with that, we're going to have our guests introduce themselves and how they use SRT to solve some really, really cool problems. And considering the nature of the guests, I think a lot of you, right, every weekend are actually watching SRT streams. So we'll get into where SRT is being used. So maybe we'll walk through, maybe guys just introduce yourself, in a full nutshell, and we'll start with John. And what do you do and how do you use SRT?
Sure. Good afternoon, everybody. My name is John Cave. I'm Vice President of Information Technology for the NFL, focusing mainly on the football technologies. Instant replay is something that falls under my area. And a number of years ago, I guess it was back in 2014, we began centralizing instant replay back into New York, which meant in New York we needed a live feed from the broadcast truck, just like we get in the stadium. And we also needed to see whatever the replay official was looking at in the booth and showing to the referee on the field. So we needed that back in real time. So we can communicate with them, and we're all looking at the same exact frame at the same moment. So What we did in all of our US stadiums, we put in quite expensive network connectivity to get back to New York, IP VPNs. But then we also had London games, one-off, a single game in London, and now we've added Mexico City. We said, wow, it's going to be pretty expensive for us to put in this network infrastructure for one game. But then we were reminded about SRT, and it was as simple for us as taking an SDI feed from the broadcast truck, putting that into an encoder. We had at Wembley, they would give us a handoff of 1 gig, but we're not using close to that. But basically direct internet access, and we would VPN back into our office so it all stayed, internal. But SRT allowed us to send the content over the internet, basically reassembled on the other end, and we only had to add 4 times the round trip latency. So London to New York, the latency is 70 milliseconds over the wire. The calculation for SRT, the recommendation is you take that, you ping the other end, and you say that's 70 milliseconds round trip. Multiply that by 4, it came up to 280 milliseconds, roughly a quarter of a second. That's what we set in our encoder and decoder. And back in New York, they're seeing basically live content, 280 milliseconds behind what we're seeing in London. And gosh, we're up in minutes. It doesn't take very long to set this all up. So kudos to SRT for allowing us to do that.
So the actual use of the workflow, the guys in London, there's a flag, the red flag goes down, right? It needs some collaboration with New York. And so he's spinning the replay dial, and New York is seeing exactly the same thing.
We're seeing exactly what they're looking at on the field, what the official is looking at when he goes under the hood. We're seeing the same thing that they're looking at in the booth, making sure they're sending him the right information back then. We've since made some changes, and now we have centralized replay, and we still use SRT for all of that for those events. If I were to go back to it, would I think about how I do it all the stadiums and maybe use SRT for everything? Possibly. We also had another use case where our red zone channel, we have our red zone channel. Hopefully a lot of you get to watch that and probably don't get to take a break and go to the bathroom because it's so intense all day long. But we need to feed that from LA all the way back to these games. If a game is in the same 1 o'clock window in the Eastern time zone in London, we want to show those highlights from around the league. Same thing you see when you go to an NFL game here in the US. You want to see those highlights in the red zone. We are doing the same thing, and we have an encoder out in LA that is SRTing all the way to London, and we're basically taking that SRT feed out. We then multicast it local for some other operations, and we also supply the output into the IPTV system in Wembley so that everyone in the stadium can tune to a channel and see the red zone channel.
Awesome. Very cool. So we'll get back to you with everybody with some more questions, and just to let everybody know the format. I want to, we have some questions I'm going to ask, and then we're going to open up to everybody to talk about different use cases and poke around at the technology. Glenn, why don't you tell us your story about?
Sure, no problem. So I'm Glenn Scanlon. I'm the Senior Director of Transmission at ESPN. I manage a team that is responsible for the ingress of all content for our linear and nonlinear platforms. So whether it's a program that's specific to our air or it's for highlight purposes. The group also manages the distribution of our content to our cable affiliates and to our OTT platforms. So we started using SRT back in September of 2016, and we use it to distribute content from schools. We have rights agreements with 14 collegiate schools, or conferences, excuse me, to distribute content for them, fully produced content back to Bristol, and then we receive it into our gateway, and then we transport streams over to our decoding farm. So it's been a wonderful experience for us. We've done 2,200 events since September 2016, and I think looking back at our incident reports, I think we've had 8 issues that are transport related, and I can't even say specifically that they are SRT related, but so it's not 5 nines, but there's a few nines in there. So for us, it's been just wonderful. It's an easy to operate system. The schools are very happy. They're now able to show content from our events that would normally not be on TV. Now it's on a national platform. As long as you have a cable subscription, you get the ESPN Everywhere subscription with that. So it's school produced, and it's been wonderful. I have to say that if we had to do this with traditional satellite uplinks or even a managed fiber solution, our E3 platform would be very different right now. We wouldn't be able to do the volume that we do. Just 2,200 events alone would be somewhere between $8 and $9 million in uplink costs. And for this type of programming, that's not sustainable. I mean, to be honest, we could have 20 eyeballs on an event or we could have 10,000 eyeballs on an event. So, so this has enabled us to just get as much content out on that platform as possible. And we've also used it to back up a program that's on our linear networks as well. So it's just proved to be very beneficial to our company.
I think that's amazing because it's just really that quest for more content, right? And getting more produced content onto the platform, because that's what it's all about: more content and less cost.
Yeah, there seems to be an insatiable appetite out
insatiable
there.
appetite.
So.
Well, great. Thank you very much. Dave, from Azzurro, why don't you tell us a bit of, I don't know everybody knows certainly NFL and ESPN. Why don't you also tell us a little bit about Azzurro?
Sure.
And if they don't know, and how you're using the technology.
Sure. So I'm Dave Lanton. I'm the VP of Technology at Azzurro Group. We're using SRT to do broadcast quality contribution over the public internet. Azzurro HD, the first all-digital video switching center in the US. We started with traditional point-to-point video fiber and interconnects to satellite earth stations, long-haul fiber carriers, and broadcast networks. Now we operate a hybrid network of traditional video and IP broadcast video. And we do turnarounds between the two technologies for our clients. So we're the on-ramp and off-ramp for IP for broadcasters who don't have the in-house technology to send and receive directly. We operate a 24/7 network operations center where we can monitor and manage all of our clients' endpoints. On the IP side, what started as an MPLS network with bonded T1s has morphed into a combination of MPLS and public internet connections with encoders and decoders using SRT. Everything we do is offered as a fully managed and monitored service. So most of our customers are broadcast people, but not necessarily computer people who understand IP. So we offer a plug-and-play solution that's cost-effective compared to getting a satellite truck or installing dedicated fiber with a long-term commitment. We use SRT in our two main IP products, the Azzurro TX and the Pop-Up Studio. Each has SRT-enabled encoders and decoders and are portable, so they can be plugged in anywhere there's a broadband connection. Azzurro TX is a portable transmission system designed as a satellite truck replacement. It has two encoders and decoders and VoIP phone lines for IFB and PL, and a multi-viewer so you can see all your sends and receives. Clients use the Azzurro TX in places where a satellite truck and space is either cost prohibitive or logistically difficult. For example, we did a satellite media tour from the W Hotel in Times Square from the penthouse suite. Cabling down 50 flights of stairs was not an option. So we used SRT and basically transmitted over the hotel internet back to our NOC, where we decoded the signal and then fed it on traditional fiber to an earth station who was able to send it to all the broadcasters receiving the media tour. Some of our clients who either own or rent our Azzurro TX briefcases include the NFL, ESPN, CNBC, Turner Sports, just to name a few. Our pop-up studio is a complete live shot production studio in a suitcase. It can be used anywhere you need a temporary or permanent live shot studio that can be completely remote controlled from the broadcaster's head end. So you don't need any technical staff on site once it's set up. It's become very useful for news bureaus and for at-home analysts, where all functionality is controlled from the broadcaster, and anywhere you have broadband, you can set up a TV studio. You can remotely control the camera, the audio, lighting, IFB, all the functionality is remote controlled. And we use SRT for the encode and decode to send multiple camera signals back to the head end and to feed program and prompter back to the remote, all with low latency. We have bureau or home analyst cams for a number of clients, including the NFL Network, Fox Sports, CNBC, and Kevin O'Leary from Shark Tank actually bought 3 of them and put them in his various homes and offices around North America. So wherever he is, he can do live shots on CNBC or any other broadcaster. So at the Azzurro NOC, we actively manage all of the systems that are deployed. Using a VPN tunnel, we can monitor the heartbeat of every single component inside the kit. And if there's any issues, we get an audible and visual alarm. We can see a low-res thumbnail of all the sends and receives, and we can remotely reboot components if necessary. So the takeaway from all of this is our end users don't have to be experts in the technology. They don't even really need any training. Once the system is powered up, our NOC can take control and test the bandwidth, optimize the SRT streams, and get the client on the air. Clients can call our NOC anytime, 24/7, with questions or for hand-holding. But the majority of the time, from the customer's perspective, the box works auto-magically. And it's all possible thanks to SRT.
Now, the crux of what you do are remote interviews, right?
Right.
And I remember years ago the bonded T1 MPLS network, right? That was costing how much at an endpoint, like $3,000 a month or something like that?
It depends on the location, but yeah, it can be upwards of that, and you typically have to get into a 3-year commitment for
yeah, exactly.
for the site.
It takes 4 months to commission, a 3-year commitment, and $3,000 a month. So it's, I mean, that's that was the state. Now the new state, I was talking to a broadcaster. I don't know if I probably can't say which one, but they're doing 51 live channels to OTT out of their facility, and they're spending $10,000 a month, but they're getting 20 gigabit per second, right? So the times are changing, and there's an abundance of bandwidth. It's low cost. It's public internet, and that's what people are turning to use for a lot of their challenges. So that's kind of a cool transition, and where SRT really helps. Let's move on, and Jeff, has everybody heard of Microsoft? Right? A little company that some guy started up in the Seattle area. Jeff, what do you do? What do you do at Microsoft, and what's your use case?
Yeah, so Jeff Tyler, I'm media experience lead for our events and production studios at Microsoft. So our use case really, it's we have, we're a large company around the globe, and a lot of different product groups and a lot of different people working on different work streams, which means a lot of video, frankly. So our production studios facility in Redmond, where I'm based, it's a full service end-to-end production facility. Content creation, live production, post house, and of course the live streaming and broadcast, which is the best part. And so really, we do, I think, we're about 500 live events per year right now, which, for some people that's probably a lot, for some people that's nothing. But of those, about 440 or so are sourced from other places around the globe, not taking place there at our sound stages in Redmond. And so, being able to efficiently move video around the world is super important. We do quite a range of events, from things where, kind of like you were talking about, where, we have some things that might just have a couple dozen viewers, they're very targeted. And then we have other things that have millions of viewers, right? So, and everything in between. So we have our high level, keynote tier 1 event things where we're doing, satellite trucks and fiber and cellular and IP, right? And lots of options there. But we also have a lot of things from all around the world that are, hey, a remote subsidiary in Europe wants to live stream something, and they don't really have the local expertise. So they call us, say, hey, can you guys help us stream this? So then, in those cases, sometimes we don't even have time to put boots on the ground over there. We're really working with their local team. So it might be an AV production team that really doesn't have a lot of experience with live streaming. So we need to help them get those feeds out of their locations and out to where we need it to go. Most things we actually backhaul to our head end in Redmond, and some things we take straight to the cloud depending on the situation. But it's really about, some of these things are at awesome venues that have connectivity and options, and some places are, it's a hotel venue where the same people doing the internet on site there are also the ones doing the catering and the AV in the room, and so it varies, and so we really have to help these people, and it's what we like to talk about, going from unknown infrastructure to known infrastructure. Help them get those feeds out of their venue remotely to where they need to go, and then we manage it all from there for them. So they focus on what's going on in the room, and we focus on getting it out to their audience. So for us, we've always wanted to find deployability is a big word that I use a lot, and it's not a real word because it gets little squigglies in Word when you type it telling me it's wrong. But I like it because we always want things that we can pre-configure, encoding devices that we can pre-configure, send out into the field, and it picks up a DHCP address and just sends the feed home. We call that ET-ware because it doesn't do anything else, it just wants to phone home. And they don't have to open inbound firewall ports and things like that. It's just they plug it in and it sends us the video feed. And so we kind of started with SRT by using High Vision appliances that had just over the last couple years that have SRT on board, and we found that works great for these IP point-to-point backhauls and has really been a huge success for us in these events. As far as some of the other challenges we face, though, it's also open internet contribution always has risk to it, right? So that's where SRT, and we have a lot of tools in our toolbox, but SRT has become a major one because it's secure. So for our internal comms events, we can make sure that everything's encrypted as it goes out over the internet. And then it's also that extra reliability. It's UDP, so it's as efficient as possible in the network, but also with the error correction, the packet recovery, things like that, that we can really rely on it, to get those feeds out. And so since we've been using that, we've gone to more and more IP-based contribution. I think it sounds like everyone else as well, where places where actually before we might have brought in a satellite truck, now we're saying, hey, we actually can do this with IP, especially if we can do multi-path bonding, right, and go out over multiple ISP connections if possible to have a little bit of extra diversity. So for us, it's been a huge success. And then there's also the fact that, I think what you were saying, I think it's over 100 now, right? The members of the
107.
107 people have joined the alliance, and many of those are encoder and decoder manufacturers. And I see we've got Wowza here, Teradek here, people that have integrated SRT, and that's awesome because then you have that interop, right, where it's built into things on all ends. So yeah, we started with Cto encoders from High Vision, but now we're also able to use Teradek cubes with SRT. Mm-hmm. We're able to push into Wowza with SRT and a lot of other things as well. So that momentum, I think, is actually makes us want to continue to use it because of that ability to work with other products as well, and encoders, decoders, you name it.
Somebody from the audience remembered to ask me why High Vision did this, because I see whatever different encoder companies jumping on, so ask me later. But one of the cool things that you mentioned is getting in and out of event centers, and it was actually one of the first improvements to SRT that we made was actually establishing the sender-listener type of mode so that you can easily get through firewalls, and we've added a lot of features in that same vein to make it very, very IT friendly, to have multiple streams going through the same tunnel, to have bidirectional streams. So that's kind of the magic of responding to the needs of the market, but that's a key feature. So the last guy at the end, are you with a major broadcaster or software company or anything, Olivier?
I think we're a major software company.
So I'll give you a little bit of background. When we embarked on the journey, right, we needed some help. And Collabora is a global company, very, very experienced with open source. And so in the initial stages, they helped us with that challenge. But subsequently, they've been heavily involved in the open source project. So Olivier, why don't you talk to us a little bit about what you did and what you do?
So at Collabora, most of our business is helping people build products using open source software. And in the media world, we use things like FFmpeg, VLC, libVLC, GStreamer, which is a multimedia framework. And we've integrated libSRT into VLC and into GStreamer. So I'm really happy about VLC because it's something that lots of people use, like real people.
How many people in the room know what VLC is? Right. Okay, so VLC has like 800 million downloads or something like that. How many people in the room know what GStreamer is?
Oh,
okay, whoa, that's a big number. Very cool.
FFmpeg?
FFmpeg? There we go.
So VLC now, the next version, the nightly builds already integrate SRT. So if you download the newest VLC, you can play an SRT stream as is, without needing nothing special. With GStreamer, it's really easy to integrate it into new hardware products. GStreamer is widely used in a lot of consumer-grade equipment, but also professional. So things like all the Comcast set-top boxes, the video is GStreamer based. If you have a smart TV from LG or Samsung, all the smart video, the internet video, it's all GStreamer. If you fly and there's a screen in your back seat, that's probably GStreamer based also. So all these things, they use a framework where SRT could easily be integrated now that we've done the hard work.
So the world is now SRT ready.
Yes.
Very cool. And it was actually just this morning that we learned that FFmpeg is SRT ready.
Yes, finally.
So we learned, I don't know, at 8 o'clock this morning, and this isn't something that you can market to or ask anybody to do. These open source communities, they tend to do it at their own time scale, and they do what they want. So it's a great honor that all of these open source based products have accepted the SRT technology. Cool. All right, let's switch gears, and we're just going to go free form a little bit. If anybody wants to, jump up and ask a question, but I've got a few questions that I can pepper in. Right, I'm gonna read them because I forgot them.
She has her hand.
Oh, we have a question right here already.
In general, you've mentioned public internet, a lot of you, but like Microsoft, you must do some of these over intranet because they're not for public consumption, or are they? So could you just clarify how often this is truly public internet that this is going over?
Yeah, absolutely. It's a good question, and it's something that, frankly, yes, this helps you. SRT has all these things that help you have the most reliability possible over open internet. We do also use it within our corporate network. Even though we actually nowadays have a pretty awesome corporate network at Microsoft that is great for we could do raw transport streams, but because it's very low latency generally. However, that doesn't mean it's always going to be that way. There can be spikes. There can be things happen, some packet loss somewhere, or maybe a saturated network segment. So we actually do use the SRT as well, even within our own network. In that case, we don't really care about the encryption so much because it's already on our network. But if we're doing it over the open internet, then we definitely are using the encryption features of SRT. But it really depends on the locations, right? So if we're doing something that's at one of our corporate network locations, going to another corporate network location, back to our head end in Redmond, then yeah, that's going to be SRT over our private network. But quite often these things are actually coming out over the open internet because we have things that take place not at our corporate locations. But there's actually, just this morning, or I guess it was yesterday, there was a press release about this, and I spoke about this today at the Microsoft booth. But something that we're really excited about that Haivision has built as part of SRT is built it into Azure so that there's a new Stream SRT initiative that I think Peter can probably share a link or something at some point. But
keep going.
But yeah, so this new Stream SRT solution that Haivision has just announced as in preview in Azure allows you to use our global managed network to transport SRT. So that way you don't need to go all the way across the world over open internet. The idea is, the example I used earlier was just recently we had an event in Sao Paulo, and we needed to get that feed back up to Redmond, right? And it's open internet all the way there. There's a lot of risk there. There's a lot of hops, a lot of places where there could be some packet loss and other things going wrong, right? But what we were able to do is we can spin up now an instance in the Brazil local data center, and then also spin up an instance in our West US data center. So that way it's very short hop over open internet, managed network all the way back across wherever it needs to go across the globe, and then pull it back down the shortest distance possible over open internet, and all of that with SRT. And this new product, actually, it's two components. There's a packager side so it can work with all these other tools, whatever encoder you have, whether it's RTMP, TS, things like that for whatever encoders you have. It packages it for SRT, and the nice thing about this is we've been doing this for a while manually, building these types of global instances to transport on our network. But now it's a product offering, so it's managed end-to-end for you. So you just say, hey, I need to be able to transport a feed from here to here, and it'll configure it all for you. So it's a very lightweight app that goes on a PC, at one end, and then it spins up all the instances that you need and manages all the transport over Azure. And then on the other end, you can either flip that, the component there in Azure can flip it to other formats again, back to TS, back to RTMB, back to other formats, and then or you can keep it as SRT. If you don't want to just go directly into a cloud workflow, you can use that, and we pull it back down to our production facility on our decoders, and then it's on our video router there. But we really like that because you get that extra, the managed network instead of open internet for the full path.
And just to be clear, the open source SRT is good for the propeller heads and the engine builders, and this Stream SRT solution is to bring that level of accessibility to a very easy to use implementation. So it's kind of okay, we did this for the propeller heads, now we're doing this for the people who might not know how to build software in Linux or whatever. Another aspect that I just wanted to point out is kind of the nature and the spirit of SRT. And Mahmoud, you had a slide before that it's totally payload agnostic. So this isn't a packager that's designed for H.264 or HEVC. You can run high bandwidths through it. You can run it over clean networks and take advantage of its security, or let's say the next feature, which might be redundancy or whatever. But it's really totally agnostic. So it's a framework that you can use for a lot of different applications. And when we were at the members meeting, people are using it for a lot of different applications. SRT 1.3 removed, if I'm saying this correctly, Mahmoud, removed the timing gates, which now enable SRT to be used for file transfer. For example, we don't use it for file transfer, but the technology is there to provide very fast UDP-like transport with the security and protection of packet loss recovery and the other features. I'm trying to remember. Does anybody from the audience have other questions for me, the panelists? Sure.
Hello. Is path diversity part of the protocol natively, or do you have to support that outside of the SRT? So if I had two internet paths, how does that work? That's
a feature that we're contemplating. It's not yet in SRT. We're starting to, as Haivision, right? We're allowed to, be ahead of the game, because we are ahead of the game. So we're starting to introduce that within our products, and then as soon as it's stabilized and works within the layer of our products, we roll that into the open source community.
Thank you.
Speaking, I'm just going to start going freeform. Are there any things that you guys have noticed, or things that you'd like to see in the SRT protocol? Does anybody want to jump up and answer that?
For me, it works perfectly. I mean, the fact that it's open source now, it just even just opens up future opportunities for us. And now we're not. Everything was a silo before. Really, you had that same SRT protocol on both ends, or any other packet retransmission protocol we're using. So now, you've already done what I needed. So
now you've got. I mean, you all have very specific workflows, right? And it doesn't start or end with the SRT pipe, as it were. You have a particular instance in your workflow. You're going into a gateway and then to a bank of Evertz decoders, correct?
Yeah, we call it a as-is solution. So it's really just we present transport streams to this. We'll call it a decoding transcoding farm. So it can take in baseband J2K MPEG-4 and puts out J2K, high bitrate MPEG-4, and low bitrate MPEG-4 to feed our plant, and for archive and for live purposes. So, and IPTV for that matter. So
what I was getting at is interoperability is key, and I was so thrilled that the 100th member of the SRT Alliance was Sencor, the world famous decoder company, and any encouragement that us as a team, or people who are pushing the adoption, any push that we can give to any other vendors to adopt this technology is always welcome, because you guys rely on interoperability, correct?
I would say, to your question about what do we want to see, it's not as much what we want to see from SRT itself being built into the protocol. I think that the bonding, multipath stuff is huge. That's something that we always want. Two things you need for success are redundancy and diversity in your signal path, right? We see people do that sometimes where they have one encoder pushing out two streams on the same network to the same endpoints, and it's like, well, that's not really fully redundant. You still have a lot of single points of failure in there. So right now we do that actually with multiple encoders and things, but having that just part of it I think is awesome. There's also, though, it's really just what you're talking about, getting it more and more hardware and software vendors starting to build this in, and we're seeing that happen already. But same thing, we're using Ericsson decoders, we're using AdTech encoders, elemental encoders, Sencor decoders, and the more of these things that are starting to build this in really just makes our jobs that much easier, because we don't even have to flip it around at that point, right? It's just native, and it might be doing that under the hood, but it's that many less points of failure, the less pieces of gear it has to go through.
Yeah, I agree. We use the High Vision Media Gateway in those instances where we're not using a Cto X, which has SRT built in, and for the last couple of years. And now going forward, we may be able to feed things to new clients or receive from clients without having to add that extra layer of hardware.
Exactly.
It's all going to just be compatible.
Yeah. Exactly. For instance, like I guess Teradek is in the room, like a Teradek encoder feeding the entire SRT workflow. One of the other things that we were talking about as far as the developments, and Dave, I think you're facing this, where you get into a place and you might have variable bandwidth.
Yeah, traditionally when we've worked with the SRT encoders, it's always been on a broadband connection on a hardline Ethernet with some guaranteed upload speed.
Right.
And there's other solutions out there that are designed to work on variable bit rate, or not so much variable bit rate, but variable bandwidth availability, exactly. And I understand that is now going to be part of the Cto X
it's part
feature
of,
set.
Just to get everybody to understand, SRT as an open source widget, an open source node in your network workflow, it's been built and hardened with an API layer around it so people can integrate it and use the information within the SRT grouping to their benefit. And the spirit of that is that ecosystem attachment at either end can react to the information within the SRT pipe. For example, SRT will tell you, of course, the packet loss because it has to recover from it, but all the 4 major characteristics of a network connection, which are, if I can remember my old high school 101 stuff, it's the jitter, the packet loss, the latency, and the bandwidth. So by detecting changes in the bandwidth and having that available on an API, vendors can attach that right back to their encoding engines. And as a vendor who's playing in this SRT world, of course, we know that inherently and have attached that detection back to the encoding bitrate so that the encoder can ride the available bandwidth and assure the best signal at all time going into the network. So that's kind of not an SRT development. It's kind of, okay, well, here's this strong widget that's API based, and how do you best use it? Mahmoud, do you have something? Hang on, maybe get a mic to him. So everybody, this is Mahmoud Al-Dakak. He's the CTO of High Vision. And certainly, I mean, we're all fully vested in SRT and this open source movement. And his team, just to introduce them right at the back, Mark Simonowski and Adam Yellen are the two main guys that make everything happen.
Absolutely. They made the whole thing happen. So I'm very honored to work with them. Just want to clarify 2 things. One, on the network adaptive encoding. I mean, it's attractive. Everybody loves it. It's a great feature and whatnot. And they say, well, when are you going to do this with SRT and what's the relationship with the SRT? It's really independent of the SRT. What SRT does is it provides you with the stats, the buffer levels, and things like that to make a decision on your instantaneous bandwidth available. And then you can tell the encoder to throttle up and down how you need it. So if you want to build your own network adaptive encoding, you can build it based on all the stats that is coming from SRT. That's how we build it. I'm sure you can. So it's not something as part of SRT. What could be part of SRT, what we demonstrated last NAB, and people ask, you have full path redundancy with SRT, you're keeping it to yourself, High Vision, and what does that say? And we tried to convince them that, no, we don't do that. Actually, we showed it as a prototype at the application level that was a little bit abusive on the bandwidth, on the CPU utilization. It works on x86. If I release it as such a prototype, no one will use it. Teradek cannot use that. It will, eat a lot of the power of that box, right? So in the member meeting that we had, we just announced that we will be releasing actually full path redundancy at the UDP level and the SRT level, so everybody who is using SRT will benefit from path redundancy that we demonstrated last NAB. This is our commitment to the open source community to enhance SRT.
Are there other questions from the crowd? Yes.
Glenn mentioned J2K. What's the highest bit rate that can be tolerated with typical processor?
Guys, do you know who has exercised SRT at the highest bit rate? Have you heard, Mark?
I know 100 megabit streams live, but there's no limit except for your CPU that has to encrypt this.
There's nothing inherent in SRT that actually says, there's nothing inherent in SRT that says, okay, this bitrate or that bitrate. It doesn't know anything about bitrate. It's packet level. It's content agnostic. It doesn't know about bitrate. It's just traffic of packets. If you have the bandwidth to sustain it, then it works.
That is a good question, though, as we're doing more and more, we're moving to do more and more IP-based signal flow, even within our facility, and less baseband. We're doing a lot with J2K, and I think that's actually something we need to test to see how does that work with our existing. It sounds like the SRT itself, no problem. It's the hardware that and software that we're using it with making sure that it can handle those higher bit rates. Yeah.
Are there further questions? Yeah.
Thank you for the presentation. I'm wondering if you can talk a little bit about the technology, like, for example, other technologies use forward error correction and ARQ for retransmission. What is SRT doing? And the other part is, if we want to reuse the code, is there any paperwork to do?
Well, let me cover off the paperwork. Yeah, it's SRT is open source. You download it and you use it, right? It's distributed under Mozilla public license, which allows, which protects the source code rather than dynamic binaries, if I'm correct. And so it allows you to do a tighter integration with your products, because you can just go right in there. But what these licenses say is that if you modify, and Mahmoud, correct me if I'm wrong, if you modify and productize the code, you need to deposit your modifications back into the repository. And that's how the open source code gets stronger and stronger and stronger every time somebody touches it, finds areas of improvement, and improves the code. Actually, the very first, I remember the story, and stories are great to get people to remember. I think the very first contribution to the SRT open source stack was, I think, by a 19-year-old intern at a company called Churchill Navigation, who found something wrong, and he deposited, and it made the code better. And they're not even a Haivision customer of any sort, right? So they do stream delivery from helicopters to the ground for disaster surveillance and stuff like that, I think. Is Churchill Navigation in the room? No? Okay. I know they're on the show floor. Go check them out.
On the open source nature and the contribution. So yes, we decided to change from the LGPL to MPL, the Mozilla public license, based on certain requests from users of SRT, where they said, well, that's great, I want to build it into my mobile app. I have to statically link, what can I do with that? Some other people said, well, it's great LGPL, but I'm still scared of it infesting, so to speak, my executable. So that's why we said, okay, we're in to enhance the adoption of this. So we moved to the Mozilla public license, which is protect the source code, but not the executable. So basically you can do whatever you need. So it's more permissive from that point of view. What you mentioned, Peter, about if you do modifications and whatnot, you're obligated basically to make them public. And then, within the open source community, the governance, you can try to say you submit it, and then if it is accepted, it gets upstreamed and then contributed. So your obligation under the Mozilla public license, if you modify the code, you just need to make it public, available to anybody who says, can you please give me your modified code? That's it, right? And then, if it is upstream, then it gets contributed, whatnot.
But if somebody were to, if they're using the code and they're not modifying it, they're building their own layers on top of it, that would still be their proprietary IP, right?
Exactly. Okay. So basically, anything that doesn't modify the code itself of SRT, it's yours, right? That's the connection, and then you call it the connection layer, and then your application itself. That's all yours from a source point of view. When you create a library, the problem with LGPL, you create this separate library that gets dynamically linked at runtime, and that becomes certain problems. This way you can actually all compile it, put it in one static library, and then that's how you have it. So yeah, we don't touch the code and it remains yours. On the specification or like the technology, we've been asked a lot. We have very, like we have a lot of products in the company, so we're trying to run as fast as possible to support the open source community. So the big questions is, can you publish your specifications, and can you do an RFC, something like that? So we shared with the members, some of the stuff that we already have at Haivision to document, the packet structure, the data flow and whatnot. And we will hope to actually put it on GitHub very soon so that at least you understand exactly how it is working. We're aspiring within hopefully not too distant future is to publish a full RFC so you can understand fully the protocol, and if you want to do your own implementation, you can do that. But again, bear with us as we try to run as fast as we can to publish all these things.
One of the questions that everybody asks, and you mentioned the 3 letters RFC, right, is the standardization. And clearly, the position that many people have is adoption is the path to standardization. But the RFC, that's kind of a technical word on the way into the standards boards, isn't it?
Well, I mean, it depends on the different levels. You can, it goes into a draft mode, review mode, and then a standard. But at least just, reaching the draft mode is good enough because it provides people exactly what it is. And then it might take years to become a standard. The point is not necessarily just to become a standard, it's more for people to understand exactly how does this protocol behave. Because sometimes it's not just enough to have the source code and try to reverse engineer how it is behaving.
Speaking of standards, guys, standards for all of you is one of the most important things, yes?
Yeah, so one of the things that I would, in addition to just the standards, because we're actually not doing the development on top of SRT, but we have, I'd like to see more adoption in the manufacturers of cameras. I would love to see like a PTZ camera, which I'm controlling over an Ethernet port. Can that be just outputting SRT? We have an initiative where we're putting cameras in every stadium this year, and I've got to connect it via Ethernet. I can control it anywhere in the world, but I've also got there's SDI coming off of that I got to throw into an encoder. But I would love the standardization going out to all the product manufacturers to say, hey, let's build this right in. Let's get it done and make everyone's lives a lot easier.
Perfect. It's 3:07. Before we wrap up, are there any final comments? Olivier, Jeff, anything that we'd like to say? Any final questions from the audience?
I'll say this. I would love to see SRT and protocols like this really start to replace our TMP as the de facto internet ingest protocol. There's nothing inherently wrong with our TMP. It's just it's so widely used because it's so widely used. But it has a lot of downsides, especially when you start adding network latency and things like that. And if you want low latency, if you need multi-channel audio, if you want to use other codecs besides well at this point H.264, our TMP doesn't officially support that. The spec is old. So what I would just love to see is it's not just the manufacturers of equipment, but also the streaming services and places like that where people are pushing into. The more adoption we get there, I think it's going to be better for everyone. It's just more reliable, better quality, potentially video throughout all of these different streaming services.
And like I started at the beginning, you've got and Jeff's RTMP stuff. You've got the streamers, and you've got the broadcasters, right? They both have kind of similar and unique challenges, but this wave in the market is helping out the entire streaming community, which is kind of cool. Towards that end, are there before I go to finish, are there any other questions? Because we're here and it's your time. Our time is your time. Speaking for my friends on the panel, too much. You guys have no appointments?
Just a very quick question. I've heard everyone talking about H.264, but is anyone doing anything with HEVC, and where do you see that going in what you're doing?
So I can speak. At our booth, we have a demo of SRT with HEVC 4K 60 frames per second. and we're using a Haivision KB Max encoder on one side, and we're using a Xilinx dev board on the other to show the interrupt between two completely different platforms. And it took us more time to get the SDI link working into the encoder than the SRT part.
Especially with 4K streaming becoming more common, I think HEVC is really necessary there. And as it's starting to get more support on devices and other things, it takes off more. But the quality you get per bit rate makes it awesome for places where you have limited bandwidth and things like that. And so right now we're not using it for distribution, but we are using it for contribution and transport. And then down the road, EV1 and other things are coming around, and that's why it's nice that all those things theoretically should work with SRT as they come to fruition, as long as it's if you give it a valid transport stream compliant input, right? I think that should be supported across the board.
And what we're seeing is all of the SRT Alliance member companies. I think they've gone through phase 1 of integration, where they achieve a certain amount of compatibility, and then everybody at this point is starting to poke the technology this way and that way and see where it lands. So, the adoption is one thing, and then you've got guys who are poking and poking and poking, and then making the open source better and better and better, and overcoming new challenges. So it's really a wave in the market that I hope, first of all, I'm actually amazed that all of you in the room learning about this technology, and I never thought that when we made this move a year ago yesterday that we would have 107 company supporters, great clients and users of SRT around the world. And so for me, it's just an honor to be part of this movement. We're supporting, just to tail on, we have more questions?
Just one more comment to John's comment about the PTZ cameras. Ron Birdie with Matrox, and we're already running our Mavix encoders to our Mura display wall products for decode, but we've also got live scale running from a Mavix encoder up to live scale and then broadcasting down to all the social media sites, and it's set up in 2 minutes. Literally, when we tested it, it was 2 minutes and running down to Facebook Live, website, and YouTube. So literally that fast and that easy. And on top of that, now Lumens, we just announced this week that Lumens is streaming directly into our multi-viewer on the Mura lineup, and that's working flawlessly as well. So right now we're still on beta, but within the next month, the Mavix encoder will be released on the software side. Lumens as well should be out very soon. So that adoption is occurring very quickly.
That's great. I'll stop by later.
So just to let you know, I mean, we have a number of events that we actually announced at the SRT members meeting that tend to help keep the initiative going and keep the community energized and bound together. On the show floor, Collabora said that they have their stuff, but all of these companies, I believe all of these are SRT ready companies with shipping products, and I think even, Pure TV is on there, great. Teradek, Churchill, AVI West, I think they're in the room. Matrox, of course, our founding SRT Alliance founding member partner, Wowza. So go out and see all of these companies. I think most of you know who Haivision is. We're located in the Renaissance Hotel just outside of South Lower, up the escalator on the second floor, and we've got some amazing new technology and demonstrations leveraging SRT across all sorts of different workflows within the broadcast community. So with that, I'm going to thank our panelists, and we'll take a break, and I think we have some refreshments here. We can network. I think the guys are going to stay around for some questions, meet and greet, and thank you all very, very much for attending this session on SRT.